All right, a very quick announcement first. As I mentioned before, I won't be able to make it to the lectures next Monday and Wednesday. So instead, what I will do is as follows. Let me mention very quickly. I'll confirm with you the where you should go for both sessions. But I'll tell you the time first. The time is confirmed. So for this Friday, okay, this Friday will be November 15th, okay? So 10 a.m. to about 11:20, it will be a makeup lecture for next Tuesday. Okay? Oh, sorry. You'll be a makeup lecture. Okay. There'll be 2 makeup lectures in total. And then for this Friday, also 4 p.m. to 6 p.m. So that will be the review Q&A session. You can ask me any question related to either the programming test or the written test. I would suggest maybe you want to start studying for the written test as well, even though it's actually later than the programming one. Okay? And then for Friday, November 22nd, we follow the same schedule just to make up for the 2 classes. And so we got 2 review sessions and 2 makeup classes. Okay? I'll confirm with you the venue, the lecture hall you should go to. It turns out it will be a different rooms. Okay? I'll confirm with you. I'll write it down later. Okay? Try your best to come. I will try my best to record the sessions. But if you come, you can interact with me, you can ask questions. I think it's more dynamic, right? I think that'll be better for your learning. But try your best. If you got classes, it's understood. All right, let me go to our topics for today. I think it would be worthwhile to review the cast a little bit, okay? Basically, we're gonna develop further about our notion about typecasting, okay? That's basically the anatomy of a typecast. Okay, that's something you can study, but I would like to go back to explaining that on the iPad. Okay, I think that's really important. And there's something I didn't quite mention explicitly, which I would like to mention first. Basically, what we're doing is you can see that we're declaring students S with the static type students, and then we are trying to use a dynamic type because it's after the new keyword, so it's dynamic type. Resident students, that's the dynamic type. And this will be valid because this particular dynamic type can fulfill all the expectation on the students because it's a subclass, right? That's something we keep emphasizing. This one's all well. However, we said before, if you simply say resident students RS, okay, you can see this is just another static type for this new variable RS. If I simply say RS is assigned to S, and we have seen this many times, it simply would not compile. You'll get a compilation error on Eclipse, like red underline. The reason is this particular static type is students. And students cannot fulfill the expectation on resident students. That's why it wouldn't compile. However, if for you as a programmer, if you're so sure that the students S object is really pointing to something that can support the expectation for resident student. If you're so sure, you can do something so-called typecasting. Okay, that's something we can do. However, as I said before, you got to be careful. When you do the typecast, compiler only checks to see whether it's upward casting or downward casting. Okay, I'll review that in a moment. However, sometimes doing downward casting doesn't really guarantee you wouldn't run into exception, so-called ClassCastException at the runtime. You might run into it. I'll talk about that as well in more detail. Okay, just talk about this particular syntax over here. Okay, I want to review very quickly, make sure you're okay. Okay, let's talk about this particular line. Let's only talk about the right-hand side. Okay, let's see on the right-hand side over here, this guy here. Okay, let's focus on this guy here. Number 1, we want to know what is the static type for S. The static type for S was declared to be students. Okay, that one is very easy to look up. Okay, and now when we actually want to do a cast, you can either do upward casting to one of the ancestor classes, or you can do downward casting to one of the descendant classes of students. You can do either way. Okay, in this case, we are doing some downward casting. Agree? Okay, you can see this one here. You can see this resident students over here is a descendant of students. Okay, the student I'm talking about over here. So it's a downward casting. Downward casting, which is 100% valid. So which means this particular cast, orange, will compile. Okay, so far so good? Okay, you talk about static type of the original variable S, and the type resident student you want to cast into, in this case, downward casting. Okay. what would be the consequence of executing this cast at the runtime? The consequence would be, you can think it this way. That's why I want to present in a slightly different way from last time. You can think about this particular orange expression over here, okay? This one over here is going to give you a cast version of S, which is over here. And what's going to be the difference between this cast version versus S, the original one? What they are in common is, let me call this cast version, just call it temp. Okay? As I said before, temp, you wouldn't see that in your program. It's what's done under the hood for you. Okay? Number one, temp is also going to point to the same objects. There's no new object created. Okay? Number one. Number two, with a new static type. With the static type, whatever that corresponds to the cast type, with static type resident students. So now the orange part, which is the right-hand side of the assignments over here, what I'm talking about is this guy here, okay? I'm talking about the whole expression over here, the cast version. The cast version over here has the static type resident students. Well, that's exactly what this tab is pointing to the same objects, but from the compiler's point of view, this cast expression has a different static type, okay? Which is resident students, corresponding to this. Now, let's complete the story I didn't quite mention last time. I'll give you more example after this slide, okay? Given that this particular orange cast version has a static type resident students, is this particular assignment over here valid or not? I will circle that. I'm talking about this particular substitution, okay? Is this assignment valid? That's the question. You have all the information you need. First of all, you know the right-hand side, the cast version, has the static type resident students, right? The left-hand side, we are declaring a new variable rs with static type resident students. So now, would it compile? It would, because resident students is a descendant class of resident student itself. So it will compile. Okay, that's something I want to emphasize. Okay, so now I want to say that, I'll write it down, okay, just for completeness. So now the rs on the right-hand side is a descendants of the rs on the left-hand side. Okay, you can see it's green, right? I'll just say of rs. Okay, so it compiles. Check. Guys, any question about this particular presentation about cast? Okay, make sure you understand that because we're going to build on top of that. Yes?
So rs in the cast on the right-hand side with an ancestor, it wouldn't work.
You mean, oh, you're basically talking about what if we try to do upward casting? We'll see example. Yes, let's hold it. Stephen's question was, is it possible to say the right-hand side is a valid cast? However, when we try to assign the right-hand side cast version to the left-hand side, it might give us some compilation error. It is possible. We'll see that. Yes, hold that question, please. Guys, any question about the clarity of this? I make sure everybody's okay. All right? Good. Let's address Stephen's question over here. I want to say one thing here. Notice that we have two things you want to pay attention to. Okay? Number one is, this is the type we are trying to cast the original variable into. And this is the type that we declare a new variable to be, okay? And these two types do not necessarily have to be the same. Although typically they are the same, but they do not have to be, okay? Let's see some scenarios where they are not the same. And you also want to be able to judge whether you should compile or not, right? But the principle will just be the same as before. If you want to make sure the right-hand side can fulfill the expectation on the left-hand side. How do we make sure that? The right-hand side must be a descendant class of the left-hand side. Okay? Let's see example here. So now I just go back to our smartphone examples over here. Okay? So let's see how things will work. Okay, let me just wipe it out. Okay. Okay, what I'd like to do is, let's see this. Sorry. Okay, we got our smartphone example. And then let's first of all look at the first line. Okay? Let's say this is what we declare to begin with. So we declare some variable s statically. So the static type is Android, right? Android. That's a static type. So I'm going to put Android here. So this is the static type for S. And then the dynamic type over here is Galaxy S10 plus. So this is basically dynamic type, right? First of all, is this valid? It is, because the pink can fulfill expectation for the green. Okay, that one's very easy. Okay, now we're going to consider 3 different possible casts you may write. Okay, just give you a feel. Number 1, number 2, and number 3. Okay, let's look at one by one. Number 1 over here, you can see that what will be the, is this a valid cast, first of all? If you believe it's a valid cast, would it be a upward cast or downward cast? Downward, right? It's a downward cast, okay? It's a downward cast. Simply because Samsung over here is a descending class of its static type. So it's a downward cast, okay? It's a downward cast. So consequently, when we actually do this particular cast, it is going to give us a cast version with a static type Samsung. Okay? And then we can now do the same analysis. So now, can we assign, okay, can we actually assign the left-hand side over the right-hand side over here to the left-hand side? So my point is, my question is, would this assignment over here compile? It would, right? Because now you can see the cast version has the new static type Samsung. Is Samsung a descending class of smartphone? Yes, okay? So this first one, check, it compiles. All right, let's do the second one. The second one over here, you can see, oh, by the way, for this particular first example, you can already see this particular type Samsung is already different from smartphone, right? So you can see they don't have to be the same, okay? What about the second one? Second one, again, let's break it down into different steps. Is this a valid cast? Well, I'm trying to cast S into smartphone. Can I actually do that? If you think yes, upward or downward? Upward, right? Because, you know, S static type is exactly over here, cast that into smartphone, which is here. It's upward casting. It's also allowed, okay? So that one there, the new static type for this particular cast version would be smartphone. And the next question would be, would this assignment be valid? Basically, you're asking whether this smartphone is a descending class of the left-hand side static type. Is it? Of course. Check. Okay, you can see we basically apply the same principle over and over, right? That's why I keep emphasizing to you, right? If you haven't got it, that's okay. You can ask me in the review session, right? Just make sure you get some feel. Now, the third one is very interesting, okay? The third one. Let's say if I gave you this in the test, for example, right? Let's say if I did that. I simply ask you for number 3 over here. Let me just make sure. Okay, the pink one, number 3, okay? Do you think number 3 should compile? Okay, let me just take some thoughts and then I'll illustrate. If you say no, which part is wrong? Basically, we have broken down each assignment into 2 parts. One is about how the right-hand side cast is done. The second part is about the assignment itself. Is the first part problematic, or the second part is problematic, or both? Okay, I heard second. Anybody who thought first part might be problematic, which is the cast? If you, okay, you want to say something? Yes.
This is for the third Lightspeed Galaxy S.
Yeah, so think about this. So now, when we are doing this, are we doing upward casting or downward casting over here? Downward, okay. Remember, to judge whether that's up or downward, you only consider the static type. In that case, we are casting for Android into Samsung. So it's a downward casting. First of all, that's downward casting, so the cast itself is okay. So now I'm going to box it over here. So this cast is going to give us a cast version of the static type Samsung. So the first part is okay. But now we have to go ahead and analyze the assignment itself. So now, is this assignment okay? Yeah, think about it. Yes or no? Okay. want to say it? Yes, go ahead. Okay, you know what? Whenever I ask about compilation, if your answer contains any consideration about dynamic type, that means you're on the wrong track. I keep saying, right? Just keep emphasizing. Whenever you talk about compilation, you do not worry about dynamic type. You don't. You only worry about dynamic type when the code compiles and you can execute it. You want to see what the runtime behavior is. Okay, Stefan, go ahead.
I think it's right because this assignment works because there's no new method defined in Galaxy S10 Plus, which means the same expectation as for Samsung.
I like the observation, but that's not quite. It's a common misconception. Okay, first of all, how about this? I'll tell you what the correct answer is, and then I'll tell you why your answer is actually not quite there. Okay. First of all, this wouldn't compile, simply because the compiler, as I said, is very, very limited somehow. They only look at the static type. So they look at that and say, Samsung over here is a static type for the right-hand side. Can Samsung fulfill Galaxy S10 Plus? Well, according to the hierarchy over here, all you got to ask is Samsung over here a descendant class of Galaxy S10 Plus? First of all, is that a descendant class? No. Okay? As soon as we get no, so we know that over here, it shouldn't actually compile, number one. Okay? So I would say it's simply because Galaxy S10 Plus is not a descendants of Samsung over here. Number one. Oh, sorry. I said it the other way. Beg your pardon. I just realized that. Okay, let me write it correctly. The reason that it wouldn't compile is because Samsung is not a descendant class of Galaxy S10 Plus. Okay, I'll write it down. Because Samsung is not a descendant class of Galaxy S10 Plus. Galaxy S10 Plus. Okay, that's the correct answer. Okay, number one. So when you actually want to judge, you don't have too much flexibility. You only look at the static type. If the right-hand side appears lower in the hierarchy, it is okay. If the right-hand side appears higher in the hierarchy, then that's not okay. Simple. And Stefan's concern was like this. In this case over here, given that, according to the diagram, I'll enlarge that for you. Okay, you can see side sync was defined in the Samsung level, meaning that in the Galaxy S10 Plus, it will simply inherit that method for sure. It seems like there's no additional method for Galaxy S10 Plus, right? So your argument was, it seems like Galaxy S10 Plus can support everything that's defined in Samsung. Okay? However, you haven't considered the case that your project might be extended in the future. Okay? Because in the future of your project, you might extend some method into this particular class called M. So that means whatever that used to compile wouldn't compile suddenly. So you got some inconsistency over there. That's why the compiler wouldn't be so flexible. Remember one thing here. Compiler for your programming languages, either Java or C# or whatever, right? Not Python. Python doesn't have a compiler. Okay? But now in this case, compiler only look at the statically declared type. It doesn't really look at exactly how your class is defined. Okay? Like in this case. Guys, I would say number 3 here is really important, okay? When you review the slides or the note, please pay attention to the third line. Make sure you really understand what's going on here, okay? Any questions? Yes? Okay, you want to do some example. Let's do it. What I would do is I want to clean this diagram here, if you don't mind. Okay, what would you like to do? Android? You want the static type to be Android? Okay, let's do that first. Samsung. Okay. Apparently, this will be valid because Samsung can satisfy everything about Android. What else? Okay, so we say, oh, you mean without a new object, right? That's a good question. Okay. Smartphone over here. let's say SP4 is assigned to,
Cast it as galaxy.
yeah, I see what you mean. I see what you mean. Let me do the following. Okay, so now that would be in the right sequence, okay? Okay, we got S, we got SP2 over here, right? It's complete. And now, can I say the following? SP4 is assigned to versus, if I say, for example, over here, you know what? This may not be as interesting as the first one. If you don't mind, I'm going to change my mind. I'll use the first one. Okay, what I will do is I'll copy the first one. Okay. Okay, let's put SP1 over here. And then, however, I'm going to change this guy over here a little bit. Okay, let's do that. And then, to avoid a confusion, to say it's a really different thing, SP4 over here. And then over here, I would say SP5, SP4. Okay, let me do another one, and then we can talk about both at the same time. Okay, and then we got over here, let's say, SP6 is assigned to, over here, SP4. You want to get a cast version? Okay, I'll keep the last one here. Okay, what should I write? Galaxy S10 Plus, okay? Sure. Galaxy S10 Plus, okay? And then S? Okay, let's talk about this first, and I'll use my example as well, okay? So now, let's talk about it, and then I will just modify this accordingly to SP5, okay? We'll talk about both, okay? Both examples. Guys, let's focus on the first one first, okay? Let's focus on this guy here first. Okay? Step number one, look at the cast. Is this a valid cast? Is it upward cast or downward cast? Downward, right? Yeah. You can see S was declared to be Android, which is over here. We'll cast that into Galaxy S10 Plus, cast into here. Downward cast. Okay, so this guy over here is okay. It's a downward, I'll just say down. Downward cast. And what would be the static type for this cast version? Galaxy S10 Plus, right? Okay. And now the static type would just be Galaxy S10 Plus, okay? And now we'll talk about this particular assignments over here. Is now this assignment valid? Okay, so how do we judge? You want to see whether this particular cast version static type, is that a descendant of smartphone, which is over here? It is, okay? Check. Make sense to you?
So when you said like it creates a new temporary object,
Yeah, so when I say temp, basically that's conceptually how you can think of it. You're basically creating a temp variable that's kind of hidden from you. And that temp variable is basically pointing to the same object as S. However, that temp variable has a different static type.
but if that temporary variable has Galaxy S10 Plus and then it points to an object of status.
No, we're talking about, no. You talk about runtime behavior, we only talk about compilation. So let's not worry about runtime just yet. You might have some class cast exception, which as we'll talk about. So here we'll only focus on compilation. All you judge when you say compilation is to look at the static type and check to see whether the cast type is actually upward casting or downward casting. And then the next topic will be when things compile for the cast, you might run into class cast exception. Let's do one thing at a time, okay? Okay, guys, let's do one more, okay? Now, this is something a little bit new, but it's a very reasonable extension. Can we consider this particular assignment? Is this going to compile? If you say no, then I'm happy. All right, let's see why. Okay, again, the way to do it, please make it mechanical for you. Well, you want to really build up the as automated as possible. SP5, what's the static type? Smartphone, exactly over here, smartphone. Okay, is smartphone a descendant class of Samsung? No, right? So that's no. Okay. Always check to see if the right-hand side is a descendant class of the left-hand side. But the rationale really is you want to see if the right-hand side, being a descendant class, can fulfill all the expectation of the left-hand side, right? That's why we keep emphasizing. The reason I want to talk about expectation is because in case you forget about this rule, let's say once you graduated from 2030, if you forget, always think about the rationale, okay? That can help you. All right. After this, I want to talk a little bit about syntactic convenience, okay? That one's very easy, okay? Nothing new conceptually, but I want to point out to you so that can make your code writing a little bit more flexible, okay? Basically, what we talk about over here, right? That's something we talked about before, right? So let's say, for example, we are trying to cast a phone into iPhone 11 Pro, for example, let's say, okay? You can judge to see whether it's valid or not. I can tell you it's valid at this point, okay? And what we have done so far, whenever you're doing a cast, you're basically saying whatever that's being cast, I want to assign that to a new variable over here. That's basically what we have done. However, as you get more experienced, you might find that sometimes you don't necessarily have to create a new variable, like an alias for that cast version. You don't have to. Okay, let me show you. Remember we talked about anonymous objects? Anonymous object means object without any name. Anonymous cast is similar idea. You can do a cast and use that cast version right away without a new name. Very straightforward syntax. Okay, I'll show it to you. Number one, you can see we are doing a cast over here. Okay, I'll be careful of boxing it. So this is a cast. Okay, we're basically casting a phone which is statically declared to be a smartphone. And we are cast that into iPhone 11 Pro. So we're casting from smartphone into iPhone 11 Pro. So that's a downward casting, right? So this part over here for the green is downward casting. So it is valid. And the static type for this particular cast version is iPhone 11 Pro. So far so good? Okay. And then what you can do is, once I got this particular green, I can put the parentheses around to say now I can use this particular cast as an expression for me. And then I can simply say call a method directly on this particular cast version. So now when I say FaceTime, should that be allowed? Okay, very straightforward. Because the static type for now is iPhone 11 Pro. Does iPhone 11 Pro support FaceTime? Definitely. It's from the parent class. Even more, you can say this particular cast version dot quick take. Would that pass? Yeah, quick take is here, right? iPhone 11 Pro, so that one also be okay. Okay. However, if you say this cast version over here dot, for example, site sync, would that be okay? No, because iPhone 11 Pro over here doesn't support site sync. Okay, so that's no. Now, I want you to look at this line over here. Okay, I want you to get focused over here. Can you look at line number one? Again, line number one is okay, right? We're creating a phone over here, statically smartphone and dynamically iPhone 11 Pro. Okay, so now can you tell me intuitively, do you think line number two should be okay? Line number two. I will give you a little bit hints. Apparently for line number two here, we're trying to do two operations. We're trying to do a method call using the dot, and we are trying to do a cast. Which one goes first? Does it matter? First of all, does it matter? It seems to matter, right? Okay, so now I can tell you that if you put things like this without the parentheses, as I said before, it's going to do the dot first before the cast. If we do the dot first, would it compile? No, because let's have a look. If you put things like this, it's as if you try to do this guy here first. And now a phone over here was declared to be smartphone statically. Does smartphone support FaceTime? No, it doesn't, okay? So now this would not compile already. Your intention really is to do the cast first before the dot. So that's why typically if you want to use anonymous cast, you have to do this particular parenthesis as you saw in the previous example. That's my point, okay? Any question about this?
For the method called FaceTime,
Yeah.
I thought the runtime behavior depends on the dynamic type.
No, for now, we only talk about whether it compiles or not. We are not talking about any runtime behavior. Yeah. So be careful. Every time I ask you a question, think to yourself, am I asking you about compilation or am I asking about runtime execution? Because for compilation, you only look at static type. For compilation, you only look at, you may have to look at both. How about that?
So that FaceTime method works because the static type is unfortunate.
Well, depend. Oh, okay. Are you talking about? Okay. Let me say it again over here. Let me copy this over. Okay. So we got iPhone 11 Pro over here, and then to the cast a phone dot FaceTime. Okay. That's the line we're talking about. This line will not compile because it is going to do this dot notation first. Should it compile this one? No, because a phone was declared to be a smartphone statically. It doesn't matter what the dynamic type is. Doesn't matter. It's not relevant to the discussion here.
Yeah, but what how about when the bracket was?
Yeah, that's exactly the point. I'm saying if you miss the brackets, you're going to have compilation issue. So that's why to fix it, you want to specify to the compiler, I want to evaluate the cast first before the dot. That's the point. If you don't have the parentheses, this will not compile because it will try to evaluate the dot notation first. How do we fix it? If you want to fix it, then you can put the parentheses around over here to make sure the cast is done first. So the anonymous cast over here is going to have the static type iPhone 11 Pro, which does support FaceTime. So that'll be okay. It's a whole discussion over here.
Dynamic type is irrelevant.
Dynamic type is irrelevant when you only ask about compilation. Totally irrelevant. As I said before, keeping track of dynamic type is an undecidable problem. Compiler simply cannot handle. Okay? Guys, any questions? Yes.
So if you assume that you would compile dynamically, this would still run correctly.
Okay, we'll talk about dynamic behavior in the next slide. Okay, basically, you want to have a separation of concern. First of all, let's talk about whether things compile or not. Let's learn that. And then we go into some examples where things that might compile will actually run into some issues. We want to separate that. Otherwise, you can easily get confused. Okay? For now, we only talk about static type since we only talk about compilation. Okay. All right. So after this, let me see what the next thing is. Okay, we'll talk about some diagram over here. Okay. Let's see. So far, let me just tell you that I already did this diagram already. Okay. Let's talk about compilation. Okay. Let's say we have this particular my phone over here. Static type is simply Android. Okay. Android is over here. This is the static type. I will complete this diagram a little bit later, but let's do what we have known so far. If we only talk about compilation, okay? And now I want to talk about all the compilable cast. I'll put it in green. Okay? Compilable cast over here. So you can see I didn't worry about Samsung being a dynamic type. I don't worry about it. Okay? What does it really mean for the cast to compile? Either you go upwards or you go downwards. So that means all these classes may be cast. So that means this particular my phone may be cast into any of the shaded area in green, any of them. It will just compile. Okay? If you try anything outside this particular area, for example, let me use orange. That'll be non-compilable. For example, if you simply say, I want to cast my phone into iOS, it's neither an ancestor nor a descendant, so it wouldn't compile. Okay? So all these will simply not compile. You cannot even execute it. Okay? So far, to distinguish between green and orange, we only worry about static type. Okay? Now, inside the green area, given that things compile, that means we can execute the code. Now you have to subdivide into two categories. When things compile and you can execute the code, it may or may not run into so-called ClassCastException. So in this case, we do need dynamic type, but we're going to say that. Okay? Okay, guys, I will complete this diagram just a little bit later. Okay, before I go over some example with you. Okay, let's see the first one. So you can see the title over here, compilable cast may or may not fail at the runtime. Okay, let's see exactly what's happening here. The idea is, let's first of all convince ourselves for the first two examples, which are easy, we're simply just going to get something that's compilable, and then we'll see what happened at the runtime. Okay. Let me draw some diagram for you quickly. Okay. Let's say we simply got student Jim and then new non-resident students. Okay, it should be no-brainer. This will compile, right? Jim. Okay, let me just put everything in the visualization. Students Jim is now pointing to a non-resident students objects. Okay, so now I am only asking about should line number 2 compile or not. Only about compilation. Don't worry about the dynamic type. Should it compile? If you believe it compiles, should it be a downward casting or upward casting? Downward, okay? Let's see why. You can see over here what we're doing is we are casting Jim into resident students. You can see Jim's static type is students. And we are casting that into resident students, right? It's a downward casting, okay? So this part over here is no problem. Compiles because it's a downward casting, okay? And then will this assignment compile, as we said before? It would, right? Because now the static type for this cast version is resident students. Is resident students a descending class of resident students? Yes. So this is okay. It compiles. All right? I'll get to line number 2 in just a moment. Okay? Line number 2 compiles. We're going to execute it in just a moment. What about line number 3? Would it compile? How do we judge? What's the static type for RS? Resident students. So does resident students support premium rates? Yes. That's it. Okay? Only look at the static type. Okay, so now I will come back here and say RS over here, the static type was declared to be resident students. Okay, it support premium rate, not a problem. So now, what's going to happen if we try to execute line number 1, line number 2, and line number 3? What's going to happen? Okay, specifically, what's going to happen when we execute line number 2? Okay, 2 over here. Given that this assignment compiles, so what we will do is we're going to do resident students. That's the type for the RS, right? It's going to point to this particular non-resident student. So now we talk about runtime behavior, right? Remember what you were confused about? So now we are talking, everything compiled. So we are done with the first part. So now we are going to analyze runtime behavior. So now executing line number 2, the assignments, RS statically being a resident student is now actually pointing to a non-resident students. Is that problematic? If you believe that's problematic, can you give me some intuition why it would be problematic in terms of expectation? Yes. Exactly. Okay. Very good. Very good. So now, guys, let me write it down to you. So now, when you are executing this line over here, okay? So now we talk about runtime over here. Executing this at runtime. It will be found that the dynamic type of RS, which is NRS, cannot fulfill the expectation on static type of RS. RS static type was resident students. In that case, because you cannot fulfill, we're going to get so-called ClassCastException. I'll pause a little bit, okay? That's the interesting bit, right? Because we basically, remember the diagram was distinguished between green and orange, right? So now we're inside the green area. Even in the green area doesn't mean you're going to be okay at the runtime. Compile time, you're okay, it compiles. But when you execute the code, somehow you're doing the downward casting, but you're casting the wrong direction downwards. That's basically what's happening here. Okay, let me put it informally here. When you do the cast over here, you would think Jin is now pointing to a dynamic type objects that can fulfill resident students' expectation. But apparently you're wrong. But the compiler doesn't care. The compiler only checks to see whether you're doing upward casting or downward casting. That's what the compiler checks. Apparently, allowing this assignment to happen, we're going to have RS is now pointing to NRS objects. And now the compiler, not the compiler, the runtime execution machine in Eclipse is going to realize now RS is currently pointing to a NRS. That's the consequence of the cast. In that case, they can soon realize NRS is basically not a descendant class of RS over here, which is the static type over here, right? It cannot fulfill the expectation. So it's going to give you a ClassCastException. Can you somehow figure out the rule over here? What's going on over here? Let me help you a little bit, okay? Basically, I do have a diagram somewhere. Let me just find it out. Okay, is it here? Okay, maybe it's a little bit forward. I will find the diagram and now I'll explain to you. Okay, there are just more examples over there we can do. Okay. Oh, actually, let me redraw the diagram. Sorry about that. It's actually for other topic. Okay, let me do a little bit more conceptually over here, right? Let's say over here, we have some inheritance hierarchy over here. Let's say we got class A, okay? So we declare some objects of statically type A. And then dynamically, we're going to assign that to new, and then let's say B. Okay, it's another class. Let's say B, to be valid, somehow it must be one of the descendants of A. Agree? That's a tree, okay? And now, when we do the cast, okay, specifically downward casting, you only got class exception when you do the downward casting, okay? Upward casting is always okay, okay? So now let's say this. When I do the following, let's say I want to cast OBJ into something, okay? I'll just put a question mark over here, okay? So now, let's now draw a little bit more diagram over here. Okay, let's say we also got more classes over here, right? We may got another class over here, another class over here, right? They are the siblings, like branches, different branches, okay? And also we got here, and we got here. Okay, that'll be enough. So now I want you to look at A. Again, I'm going to use my color convention. This is the static type. This is the dynamic type, okay? A and B. Okay, for OBJ. So now, if I try to cast, what can the question mark be? Can the blue be here? It is. It's a downward casting, right? Can the blue be here? What's the difference between the two blues? What? Well, let me put it another way. It's actually easier for you to refer to. Let's say over here, let's say purple. Oh, that's not purple. That's a deep blue over here. Okay? You got a light blue, you got deep blue. Which one has more expectation? The deep blue or the light blue? The deep blue because it's much lower, right? And more precisely, the deep blue does have more expectation than the B. So that means somehow you cast too much. You cast your OBJ into something that simply cannot be supported by the dynamic type. So whenever you do the downward casting, you want to make sure you don't really cast beyond the dynamic type. That's what's happening here. Okay, I'll write it down. When doing, okay, 2 points over here. Downward casting always compile. Down casting always compile. Number one. Number two, downcast beyond the dynamic type of, for example, OBJ will cause ClassCastException. Simply because any classes strictly lower than, when I say lower, I mean in the hierarchy, strictly lower than B, which is dynamic type over here, have more expectation. Have expectation that B cannot support. Okay, guys, I know it's a bit abstract, but I thought that might be the easier way to visualize what's happening. Yes, question?
For this specific example,
yes.
you cast down to as low as B.
That's exactly right. Let me just repeat your observation. Your observation is exactly correct. Apparently, it will be considered as downward casting if we cast into A's child. This will be downward casting. That's okay. This can still be supported by B. If we cast downward casting into here, would that be okay? Still fine. Still fine. If we downcast to B itself, of course, B can support B's expectation. If I downward cast to this guy over here, not good anymore, because potentially you may have a new method here. Okay, so now, here's the thing. When you do cast, you can do either upward or downward. They will just compile. However, when you do downward casting at the runtime, you'll run into some ClassCastException if you downward cast too much. If you downward cast too much into a type that's lower than the dynamic type. Again, everything is about expectation. Yes?
But in this case, could the purple or the deep blue upwards cast all the way to A?
Ah, that's good. You know what? I will hold your thoughts over here. That will be in one exercise. Okay, I'll get there. Don't worry. Okay. Guys, any question about this? Okay. So now what I will do is I'll do one more example with you, and then 2 exercises you can complete. Okay, and ask me if you got trouble. Okay. And then we can do one exercise together, some a little bit more challenging one. So now let's do one more, okay? Just do one more. Okay, so now for this guy here, let's just, without visualizing anything, should line number 1 compile? Well, because Galaxy, this guy over here, that's dynamic type. Galaxy S10 Plus, dynamic type, is going to fulfill whatever that's in the smartphone, okay? And now, should line number 2 compile? 2 parts. Should this be a valid cast? Downward casting? Yes, good. A phone was declared to be a smartphone. Cast into iPhone 11 Pro. Downward casting. Valid. Okay? And then, should this compile? Because for Hyun over here, then statically it's iPhone 11 Pro, which of course support QuickTake. Compilation-wise, it's fine. Dynamically, if we try to run this compiled code, are we going to run into trouble? Which line? Line number 2? Can anybody try to explain? Give it a try, you know. I can correct your wording, so that will help your lab test too, right? Anybody want to try? Why would line number 2 actually fail? I can tell you that you're going to get a ClassCastException. That's what you will get. Anybody want to try it before I repeat? Yeah, give it a try.
Because you're not casting into any of the types from that tree,
Uh-huh.
tree of Galaxy S.
Yes, basically, yeah. You can see, think about it. Smartphone, okay, sorry. So now we talk about whether class cast exception will happen at runtime. So we're going to see the dynamic type. Dynamic type is actually over here. So if you cast to any of the classes whose expectation can be supported by this dynamic type, you'll be okay. You wouldn't have the class cast exception. However, what we are casting into, let me use orange, what we are casting into is iPhone 11 Pro. Can iPhone 11 Pro in general be supported by Galaxy? No. For example, QuickTime, QuickTake cannot be supported. Okay, good. Similar example, right? Okay, 2 exercises for you. Okay, I'll make it available when I post the iPad notes. Look at this guy here. Think about compilable, class exception at runtime, and another exercise for you. Okay, think about them. You can ask me in the review session if you wish. But they should be fairly similar to what we just said. Fairly similar. So now let me go back to where I was, and I want to complete a diagram. Okay? Previously, we distinguished between the green, meaning that either do upward casting or downward casting, and then the orange, which wouldn't even compile. So now we can do a little bit more distinction. We want to know whether, given that the cast compiles, will any runtime exception occur? So now, when we talk about runtime, static type is not enough. We have to bring dynamic type into place. So what I would do is, so now I can bring dynamic type, which is Samsung. Okay? So now this is dynamic type. All right? So now the question is, out of all the greens, which ones are going to give me class cast exception, but which ones are not? How about which ones will give me class cast exception? Which ones? Stephen? Yeah? Basically, well, are you sure that's the only one? Yeah, basically think it this way. The way to figure this out is like this, okay? This is how you figure out. First of all, you know that the static type is over here. Class cast exception only occurs when you do downward casting. When you do downward casting, you can either go this way or you can go this way, right? And then this one here, would that be class cast exception? Actually, yes, because Huawei may have something that's not supported by Samsung, their sibling. So that's not good. And similarly, this Huawei over here definitely got Zoomage that would not be supported, right? And also this one here as well. And then what about this class over here? Would that be a class cast exception? Yes, right? It's lower than dynamic type. So it may have something that's more than the dynamic type. And this guy here as well? Okay, so now let me draw them precisely. Basically, you have to look at all the downward casting candidates and see which ones may have something that the dynamic type cannot support. So now, I have an easier way for you to figure out, easier way. So now let's think about what may not cause class cast exception. Anything you cast into that is an ancestor class of the dynamic type would be okay. Because ancestor of the dynamic type is guaranteed to have fewer or the same expectation, right? Ancestor. So this is how I draw it. So now you can see I talk about exception-free cast. So now dynamic type is exactly over here. So starting from here, go to its parents, grandparents, all the way to the root. So these are all the classes that will not give you any class cast exception, including those that will be upward cast. And then all the remaining ones will be class cast exception at the runtime, okay? Like here. Okay, we got these 4 categories. I kind of mentioned that very briefly last time, but I think now hopefully that reinforced the idea, right? Do study this. Again, whatever you learn about this kind of idea in Java, it can be transferable to any other OO language. So it's not unique to Java. That's why I want to really make sure you're okay with this. That's important. Any questions? Okay, if you're fine, let's go a little bit further. Okay. Okay, that's exercises for you. Please do them. So let's do one exercise together. Okay, just one together. Oh, you know what? I don't want to show you the diagram. Okay, I already showed it to you. That's fine. Okay. So now what I want to make sure you're okay with is this. Did you see any? Oh, actually I didn't switch, right? So what I would do is, let me go all the way to that particular exercise, okay? Everything has been covered, okay? So I just want to go directly to the exercise I want to do together with you. So when I say danger, that means a possible class cast exception, right? That's already covered. I want to do one exercise with you, which is, we're getting there very soon. Oh, by the way, I'm not skipping anything. Everything has been covered, okay? And one thing I would suggest you try to read quickly. So there is a notes on the static type, expectation, cast, and also class cast exception. It's only about maybe 4 or 5 pages. Read them. I think it will also help you understanding. Let's do this example together. Okay, so that's kind of like a different example from your practice question. Similar style, but different example. Based on this, are you able to draw the tree diagram hierarchy? Can you do it quickly for me? Thank you. Do it. And then I'll try to make the point. And that's exactly what you just mentioned 2 minutes ago. So this exercise here, I want to reinforce again, compilable cast versus runtime exception, like a class cast exception. That's something I want to reinforce. Okay, I'll give you about 30 seconds more. Okay, it shouldn't take too long, I hope. So basically, every extents corresponds to an upward arrow, right? As we said before. Just make sure you're okay with that. All right, give you another 10 seconds. Okay. Hopefully, that's what you will get, right? Right? B extends A, C extends B, and D extends A. Okay, if you're having trouble drawing this, please let me know. Okay, I'll help you with that. All right, so now we're going to consider 2 lines over here, line number 1 and line number 2. Let's do 1 line at a time. Line number 1, should it compile? Okay, if you say yes, I'm happy. So let's say this, C can fulfill whatever that's expected on B, right? It's a descending class. Very good. Okay, I wouldn't bother you with that. And executing 1 is going to have B is now pointing to a C objects dynamically, right? So you can think about after this, the static type is actually B, dynamic type is actually C. Okay. Now, should line number 2 compile? Should it? Or no? Anybody want to try explaining? Which part is wrong? Casting part is wrong, or the assignment part is wrong? Well, let's try. Casting over here, so now B statically is B over here. And we're casting that into D. Well, is that an upward casting or downward casting? Neither. No. We okay so far? Let me propose something. Let's say I'm so confident I'm right. What about I write this? For those of you who are, all of you are very smart, you might be knowing what kind of trick I'm doing. I'm doing 2 casts. You see what I'm doing here? Before I try to do something on the diagram. Funny enough, this will compile. The reason is, my intention is, I somehow want to cast something statically as B into something statically as D. And I see this diagram here. Why don't I just go to the root and come back? And I tell you what, what does this tell you? In Java, you can basically cast everything to everything else. What do? You simply cast everything to object first, and then downcast to anything you want. You see what I mean? But is that useful? Not necessarily. So that's the problem. When you're given so much freedom on programming language, you better know what you're doing. You better know, okay? Okay, guys, so now here, apparently, let me go a little bit further. This guy here, let me just use a different color here. Okay, this guy here, it is apparently going from B to A is an upward casting, right? It compiles. And then this particular guy has a static type A. And then I'm casting from A to D. That'll be a downward casting, right? So this guy over here is, again, oh, let me use a different color. Okay, so for this particular cast, it's a downward casting. And then now the new static type will be D. And now D is a descending class of D, so I'm okay. So eventually, I managed to cast my B object, my object over here into D somehow. Oh, any questions? I heard something. Yes, please. Yes, exactly. So now, first of all, let's agree, compilation-wise, it's okay, right? You're just basically doing upward casting all the way to the root and downward casting to wherever you like. Okay? Now, when we execute this line, are we going to be fine? I heard no. Okay? But why is that? Exactly right. Exactly right. I'll write it down. The reason is dynamically, okay, what we will get eventually is, okay, if you try to do the whole thing, right? What you will get is ClassCastException. Because, number one, dynamic type of B is C. And then, which cannot fulfill expectation of D over here, right? Because that's what we are trying to assign to. Because you can see D is over here, which is a sibling of C. It's actually not even a sibling. It's more like an uncle, right, over here, right? So you can see D over here just cannot fulfill what C is expecting, so you cannot do it. Okay? Think about this example here a little bit. I know it's kind of symbolic, kind of contrived, but the main point is for upward casting, downward casting are very powerful, but you got to be very careful because when you get some cast that actually compiles, it doesn't mean you're just okay. That means you just run into ClassCastException at the runtime. Okay? Any question until now? Before I move on to a very close related topic. Yes, please. Yes, yes. Yeah. Oh, I can just write it here. It's not a problem. Actually, you know what? To really get it clean, so your question is about the, give me one moment. I will simply, give me one moment. I'll make a clean page so it's easier for us to see what's going on. Yes, go ahead. Yes. Okay, good question. The question was, let's modify this guy over here a little bit. Let's say this guy over here is dial. Let's say we do that. Okay, very good. What we're doing over here is, I tell you what, this will not compile for the following reason. Okay, first of all, we agree that it's going to call dial first, right? Okay, so that means a phone.dial. What is the return type for dial? Let's say it's void. Let's say mutator, right? Let's assume that we simply got void and dial that's declared in the smartphone. Can you cast this guy? Can you cast void to something? No, just not possible. Just not gonna compile. All right. That is interesting thought. Okay. Okay, guys, I'm gonna do one more another topic. Okay. For those of you who heard about instanceof, okay, this is the continuation topic for the story. Okay, before I don't want to scare you too much by the diagram. Okay. Let me just give you an empty page. It's okay. Let me talk about how do we connect to the next topic. We know that if you try to do some cast which you believe is okay, but it may not be the case. right? So you don't want to trust yourself too much. You want to buy some insurance, basically, right? To make sure, before I can do this particular cast, I better let Java runtime to check for me whether this particular cast is really okay to do. Okay? So for example, if I want to cast from type A to type B, I want to say at the runtime, right before the cast, is my current dynamic type able to fulfill whatever expectation it is for type B? That's basically the thing we're going to talk about, called instanceof. Okay, let me show that to you. We are just going to do a little bit more extension to what we said previously. Okay, so now I'll go over code with you. Don't look at the diagram just yet. Okay, not yet. Okay, maybe I should refer to it. Okay, number one, we got 3 lines of code over here. Okay, and the only thing that's new is called instanceof. Okay, that's a single word, instanceof. And the syntax will be, you put some variable, typically variable or some expression at the left-hand side. On the right-hand side, when I say question mark, it will just be a class name. Okay, you put some expression, instance of some class name. Okay, the instance of is going to be a Boolean expression, return evaluating true or false, either true or false. Okay, what does it really do? Okay, let's see exactly how it works. I think that'll be easier. Number one, let's look at line number 1. We are saying that obj of static type A is now having the dynamic type B. That's okay. All right? And now, as we said before, if we simply do line number 3 directly, we might run into trouble, right? Because what if the question mark, oh, actually, you know what? Let me highlight it. What will be the cast that will not cause any class cast exception? How do I highlight them? Starting from where? Basically, all the casts that will be both compilable and also wouldn't cause any class cast exception would be those that would be starting from the dynamic type over here and then go to its parents, grandparents, great-grandparents, all the way to the root. And then that's the so-called ancestor path. So these are the classes where you can cast obj into without getting any class cast exception. Anywhere else, either it doesn't compile or you're going to run into class cast exception. Okay, number 1. Okay. I'll write it down over here. Casts that will not cause any class cast exception. Okay, just short form. Because they are simply ancestor classes. If you cast to any of the light blue, their dynamic type, which is pink, can definitely support them intuitively. Okay, so now, how do I know if the question mark over here is really one of the classes in the blue? How do I know it? How do I know it? Well, the answer is instanceof. Okay? What the instanceof will do is, I'll write it down for you. Okay? When you say obj instanceof, okay? You can think about it in 2 ways. Number 1, can dynamic type of obj fulfill question mark, question mark? That's one way to think of it intuitively. If it can fulfill, then you can say true. In that case, if you say true, then the branch over here will be okay. So I'm going to go ahead and do the cast accordingly. So that will be a safe cast. Okay, another way to think of it, equally, is question mark, oh, let me say that. Let me say, just start with dynamic type. Is dynamic type over here a descendants of question mark, question mark? 1 and 2 basically are talking about the same thing. Because if the dynamic type is a descendant of whatever tab you're trying to cast into, of course it can fulfill all the expectation. Because descendants can always fulfill the ancestor, right? So either 1 or 2 is okay. Okay? But I prefer 1. 1 is pretty nice, intuitively. Okay? So now let's do a little bit exercise over here. Oh, that's just the syntax, right? Always put an expression here for the objects and then some class name. Let's do some example to really get you comfortable. Let me just do one thing for the students class, and then we'll do lots of example, in a different setup. Okay? Let's just do this guy here. Okay? So now let's get you comfortable for the very first one. So now for line number 1, we are saying Jim is now going to point to a non-resident students class, right? And then we're asking if Jim instance of resident students. What we're asking is, first of all, locate the dynamic type, which is non-resident students. Can the current dynamic type, which is resident students, fulfill whatever that is expected by resident students? Oh, sorry. Yes, can we? Let me repeat my question again, okay, just in case you're lost. First of all, we have this particular setup. Jim is now pointing to some non-resident students, right? And then we are doing this particular check. We're saying Jim instance of resident students. We're asking the following question. We're saying, is the dynamic type of Jim, which is non-resident students, can that fulfill all the expectation of resident students, which is over here? No, because they are not ancestor, right? No. So that means we will simply bypass this particular cast, which is will give us class cast exception. So the point about doing instance of is every time before you try to do a particular cast, make sure it is safe to do so. Let the runtime check in an if statement to see whether your current dynamic type is really able to support whatever expectation it is for the cast type. Let's do a little bit more comparison over here. Okay, the other one over here on the slide is similar. Okay, let me really give you the feel. You can see I got lots of instance of over here. Okay, let's do this one here together. Okay, we still have a little bit of time. Again, let's start with line number 1. Line number 1 here, we got static type, we got dynamic type, right? Let's locate them first. Static type is smartphone. Okay, that's it, static type. And then we got dynamic type over here, Samsung. Okay. So now let's try to. We already know from the previous slides which are the 4 categories over there, right? Let's not worry about them. Let's talk about instance of. Start with this one here. We're saying my phone instance of Android. We are basically asking, is the current dynamic type of my phone able to fulfill all the expectation of Android? Right? So Samsung, of course, can fulfill everything on Android because Samsung is the descendant, right? So that's right, it's true. Okay? So now it seems like, let me just say this. So this is okay. So this is an okay one without any class cast exception. What about the second one? How about this guy here? Should it be true or false? So we're asking, is dynamic type of my phone, which is Samsung, going to be able to fulfill all the expectation of Samsung? Yes, right? Okay, very good. So that's also fine. Basically shows us the type we can cast into. But instead of this, do that check for you. Okay, the next one. Now you can see, can we do, is this true or false? Okay, let me phrase the question to you. Can my phone, or can the dynamic type of my phone fulfill all the expectation of Galaxy S10? No, because dynamic type of my phone is Samsung. Can Samsung fulfill all the expectation of this guy here? No, because that guy there is a descending class, right? Okay, so false. You rather get an instance of check first, in which case you only do the cast when instance of give you true. Okay? Okay, guys, how about one more? Okay, one more. True or false? Can dynamic type of my phone, which is Samsung, can Samsung fulfill iOS expectation? Apparently not, right? It's basically just different branch. All right, so that's also false. All right, are we okay? Okay, very good. I'm glad. Okay, the next one, also in the slides, is we're basically just trying to show you how you can use instance of. You can think about it this way. Given that I want to cast my phone into Samsung, before I know if I can do it or not, I better do an instance of check to say if instance of Samsung. So these two types should always match when you do the instance of check, which is to say, before I can cast my phone into Samsung, I better make sure the current dynamic type of my phone can fulfill all the expectation of Samsung. That's basically what's happening here. Before I can cast my phone into Samsung, run a check to see if the dynamic type of my phone can support that. Can fulfill all expectation of Samsung. Okay, we're talking about you want to cast to Samsung, then make sure you can fulfill all the expectation of Samsung by the dynamic type. Okay, think about the issue, right? It's quite a long story we have talked so far, starting from extend keyword, right, and all the way to here, right? We're almost there. Okay, I want to make sure it's complete for you. Guys, any questions so far? I think we got about 3 or 4 minutes. I want to do just one more thing. Okay? Yes, please. Yes.
You can check if something is a like descendant. Like, well, when we're implementing equals in my classes, we'll use instance of.
You're talking about when you talk about equals method using instance of. I would say I'll address this issue next time, maybe later in the course, because if I talk about it now, it might take a little bit too long. Okay, guys, the question was, remember we talked about equals method, we simply say get class, right? Can you use instance of instead of get class? Okay, I'll address this more properly, maybe a little bit later in the course. Okay, for now, not worry about it. Okay. Okay, we got one more thing I want to say very quickly before I let you go. Okay, very brief. Basically, everything has been done up to slide. Everything has been done. I didn't skip anything. Okay. Okay. What I want to do now is to go to the lecture about the same lecture. Okay. So now, basically, up to now, you should study up to 63 slides. Okay, slide 63. I want to do just one more thing quickly, so we can continue on Friday. Now, remember the very original criticism I have on the non-inheritance solution, right? Is to say for every kind of students, I need to create a separate array. An array for resident students, an array for non-resident students, things like that. But now, since we got inheritance and we somehow grasped the idea about polymorphism, dynamic binding, and cast, so many things. Now, I want to revisit our student management system and see how things can work out more properly. We're going to connect all the dots together, okay? So now I'll start with this over here. Line number 1, we declare a class called student management system. Okay, it's a different class. And then line number 2, I use the type for every element in the array as a student, as opposed to resident students or non-resident students. I chose that deliberately for a reason, okay? So now I have only one question for you, okay? I'll switch to iPad. Can we have a look at over here? I have student management system class over here. I have this particular array, okay? So now, one thing to know, every element in the array, every element, like SS0, SS1, all the way to the last element in the array, their static type should just be whatever that's declared, students. Can we agree on that? Okay, every element, okay? So now, I want you to consider this particular line for me and tell me whether that should compile or not. Let's say, line number 3, we declare add RS, like add resident students. And then we declare some variable RS over here. And then I want to know whether this line should compile or not. Should it compile? I heard yes. Anybody want to explain to me? The question is, line number 3, I declare a parameter which is like a variable in scope. Statically, RS is of type resident students. So now, should that line compile? Yeah. Oh, try. Yes. Exactly. Let me just repeat it, okay? So you can see RS over here, right-hand side, the static type is exactly resident students over here, right? And now, if I look at SSC at a particular position, as we said before, SS was declared to be students array. So now the static type also is also student. So now is RS a descending class of students? Yes. So this line compile. All right. Okay, I'll stop here and then try to make it to Friday's makeup lecture. I'll appreciate that. Okay, see you then.